The main goal of using the chain rule is to take the derivative of a composite function. The chain rule states that the derivative of f of g at x is the derivative of f at g of x times the derivative of g at x. So basically, the chain rule is telling us to take the derivative of the outer function in respect to the inner function and then multiplying that to the derivative of the inner function in respect to x. So f prime of g of x times g prime of x.
You use the chain rule when you are finding the derivative of composite functions, which are functions that have functions inside of them. How to use the chain rule. Think of functions f and g as layers of a problem. F of u is the outer layer, and g of x is the inner layer. First, you're going to differentiate the outer layer, but leave the inner layer alone. Next, you then differentiate the inner layer, and then multiply the inner and outer layers together.
For our first example, we're going to differentiate this equation, which is y equals 3x plus 1 squared. Okay, and using the chain rule, what we're going to do is multiply the derivative of the outside times the inside. Or, either way, it doesn't really matter. We're going to take the outside first in this case. To take the derivative of the outside, we must take this, the exponent of 2, and move it to the front. We also subtract the exponent by 1. And then we just fill in the rest of the equation. Okay, so this is also saying that we have, let's just clean it up, we have 3x plus 1, and that's just subtracted, or it's just going to be a little 1, but you don't have to write that. And that is the outside. Now, just to remind us, when we come back to multiply, we're just going to write a little out here. Okay, moving on. To find the derivative of the inside, we have to kind of sort of do the same thing. We just take the little exponent up here, which is 1, and we pretty much do the same thing. We move it up front, 3, and we subtract by 1. Now, in doing so, we have a 1 times 3, because we lost the x due to the loss of the exponents, and any derivative of the coefficient is 0, so the 1 is taken away. So all we have left is a 1 times 3, which is simply 3, and that is the inside. Okay. Now, we just simply multiply the inside times the out. All we do here is write 3 times 2 with the 3x plus 1, which leaves us with 3 times 2 is 6, and lastly the 3x plus 1. Okay, for our second example, we're going to differentiate y equals sine 5x. Okay, we're going to do the same thing we did in the last example, in which we multiply the inside times the outside times the in, either way what makes you feel comfortable. So what we have here is the outside, which is sine. And what we're going to do there is find the derivative of that, which is simply cosine. Oops, if I look in there. But, okay. So after that, we take the 5x, and add it on the end. So to find the derivative of the inside, we're going to do the same thing that we did in the last equation, which is have that blind little 1 subtract the exponent by 1, and then we're going to move a 1 up in front of this 5, which leaves us with a 1 times 5. And so because of the 1 minus 1 in the exponents, we lost the x. So that's how we got that. Now, just like in the last example, we multiplied the inside by the out, giving us the 5 times the cosine, 5x, giving us our final answer.